Okay, this is the Algovera DeFi hacking session. Today we don't have Richard with us. He has the doctor appointment, so we're just gonna do it ourselves without him. And yeah, hopefully you guys can enjoy it. The last meeting we left off with some next steps. We decided to expand the data sets we had put together and also make some progress with the analysis we were making. I wanted to know if we were able to expand the data sets. I think Christian was working on it. And after that, I think we can go over the notebooks that the group have put together asynchronously. And then we could just explain to everyone and go through every step, because I think there's some very great potential in the results that we found.
Cool. Sounds good. Yeah, so I unfortunately didn't get to pulling all of the extra data that we need. I only really started on it when I messaged you, so an hour or so ago, because I had some stuff going on with component, but so I apologize for that. But if we want, we can kind of look at if it's time well spent. I mean, it's up to you all, but we can look at kind of what the queries look like to actually pull the data, because so what I was trying to do is expand the loan data set on Aave and also include the deposit data set with that, join the two, and basically just pull in all the variables that we can. But I was having an issue where, so I was pulling these two things separately with two separate queries, the deposit rates and then the borrow rates, with two separate queries. And the borrow rate one, the total rows of the data set was 100,000. And then the deposit rate one was 400,000 for some reason. And I was pulling them by block, which was weird. So there's obviously something wrong with the query. So I was just doing this now, so I didn't really have time to troubleshoot it. But up to you guys if you want to go into the notebooks or maybe try and look at how Dune is working with this and where the problem is.
For me, I think it would be cool to look into Dune, and even if the data sets aren't the same, I think we could maybe filter for the blocks that we have data on both of them, and we can start working on top of them. What do you guys think?
Archie has also been looking into DeFi Llama, which supposedly has all the data. I'm not sure how they get it, but let's see if I can try to. This is the link. And I think Archie said he was gonna look more into this. And also Archie expanded the notebook with the PyTorch forecasting and was able to even train the model. And it seems like PyTorch forecasting would allow us to basically train one giant transformer model on even different protocols at once. It's not 100% guarantee, because we need to get a bit more clarity on how it exactly works, but it seems like that should be possible, and it actually makes sense considering it's a transformer which can take, and they specify that you can have different times, independent time series. So that's interesting. And also we were talking a bit about why the accuracy is so good, and I think that he managed to change the window size so that we were trying to predict farther in the future than before, and that turned out to decrease quite as expected. I think he posted the R² metric.
Yeah, but I think that R² metrics were not for the same model that you were using in PyTorch, right? Because I went through. Is it the same? Okay.
No. I think it's the Tabula Model from Fast AI.
Yeah, I was very interested with the PyTorch one because it's rather like easy. I'm not gonna say easy, but it's kind of simple to implement it, and it seems quite powerful. I actually had some questions for you. I'm not sure if you have the answer for all of them. So I think going through the notebook, I think we can discuss a lot of stuff. But shall we take a look at the DeFi llama before? I'm looking here. Uh, I'm not sure if I understand the data set.
Yeah, I was trying to look if they do have like an API, but it seems to be very
I think it's just like TVL and like
Yeah.
then the change in TVL. Maybe
okay.
the API is different though. Yeah, so they have protocols, historical TVL of a protocol. Yeah, it's just TVL stuff, unfortunately.
So that wouldn't really be applicable then.
Yeah, it's just like, yeah, I guess the total value locked for like, it's good for like a high level view of, like these different categories like lending, yield, insurance, etc. by looking at like the total value locked and I guess their market cap divided by the total value locked, but it doesn't give us like the, like the actual rates and things like that.
Yeah.
At least from what I see here.
So Christian, do you mind sharing to us the Dune part of the data?
Yep, for sure. Insurance. Oh, I need to, it says host disabled participant screen sharing.
Okay, now I'll just try to figure out how to change that.
No worries.
Yeah, okay, now you should be able to.
Sweet. Is it working?
Yes.
Nice. Okay. Okay, so where are we here? This is gonna get in the way. How do I hide this? There we go. Okay, so yeah, I guess these are my historical queries, but let's start with maybe we can start with like a simple one, like how we pulled the Alve V2 borrow rates or lending rates, same thing. No, that's not the one that we want. Which one did I just open? I don't remember.
Could you explain why the queries have to be different for borrowing and deposit? Are those different databases that they're storing?
Yeah, so let me open these side by side. So here is, yeah, this one's for borrowing rates. So we can kind of walk through why they're different, I guess, this like compared to the deposit one. And maybe actually figure out if it's necessary to even use two different tables. I think it is though. So these are the two. So for borrowing rate, the table that we're pulling from, I guess the smart contract that we want is lending pool underscore EVT underscore borrow. And this essentially is events that are transmitted through the borrowing contract. So, it'll basically give you all of the information on like a loan that was taken out. So like the amount, the borrow rates, the borrow rate mode, AKA if it was a stable borrow or a variable borrow, the contract address, all this other information. And yeah, like the reserve and the user that actually did it. So this is like where the actual data that we've been using came from for Aave, this exact query. It's probably a little messy, like it could probably be done a lot cleaner than this. But essentially it's just cleaning up like all of these metrics and showing them in a way that's, is actually visually appealing because, working with decimals or big numbers is probably the most annoying part when you pull it like without any calculations or transformations. So for example, here, when borrow rate mode equals 1, that means it's a stable borrow. And so we have to divide that by these decimals to actually get like a stable borrow rate that makes sense. And the interesting thing is that, like different assets or tokens have different decimals, I guess, just depending on how the protocol math works. So for amount, for example, we divide by 1 or 10 to the 6. But as you can see for DAI, they actually use 12 instead of 6. So basically I had to write like a little exception that when the symbol is DAI, then, this is the token amount. So it's just little things like that that are required to kind of like make sense of the data. And yeah, like this one's actually pretty simple because, we're just pulling the stable rate, the variable rate, and then, the things that we all know, like block time, block number, the transaction hash. I actually added these in today just to give us a little more data. And this is just basically joining the reserve contract. So the reserve is basically just like the actual underlying token that's being borrowed. And so we're just joining that with an ERC20 tokens table that basically just maps the smart contract to like the symbol, just so it looks nicer. So you can see here, there should be a table here, yeah. So this table has basically maps symbols to all contract addresses, as well as their decimals, actually, which is helpful. So just kind of like an ease of use thing. And there's a bunch of tables like this that are user generated. Like there's actually I think there's some DeFi Llama tables actually in here. Oh, maybe not. Yeah, so whenever you see like a Dune user generated table, that's when you'll see. So these are things that like are just generated by users. You kind of have to trust like who built them, but you can get some pretty interesting metrics here that aren't available. Like they're basically, these user generated tables are usually things that can't be decoded directly from the smart contract. So there's some kind of like manipulation going on. But you can see here, this is probably actually from, I don't know if this is from DeFi Llama or like some other DAO or something, but I think it actually is a DAO called some like Llama DAO or something like that. But anyway, this is how we pull the borrow data. Then for the deposit data, we're looking, so on this one, we were looking at the lending, essentially the borrowing smart contract. And then for whatever reason, I actually don't know why, like I probably have looked into this more. It seems that the place that you can actually grab the liquidity rate, which is used to calculate the deposit rate, is through this smart contract, which is the reserve data smart contract. So there's probably a better way to do it, but this is just kind of the literature that I found, I think, in their docs. So if we look at this table, it's essentially just updating. The smart contract is basically updating every time that certain things occur. So I think in this case specifically, it's like changes to the liquidity rate, and then the other things here like the stable borrow rates and the variable borrow rate. So it'll record like every time a change happens, which actually might be the reason why the row number is different. But yeah, this one's pretty simple. So the only thing that we care about here that's different is the liquidity rate, whereas in the other one we were looking at the the borrow rates. And so the liquidity rate here, the liquidity rate times 100 divided by the decimals is the deposit APY in this scenario, which we just pulled that from the docs. That's what I calculated.
And
So
for that line, I see that there's an average. So like
yes,
why would you pick this straight liquidity rate? Okay.
Yeah, so the only reason that was the case is because before with this query, I was pulling it by day. But so the average probably isn't needed anymore. Oh.
So it seems like for the borrowing, they are tracking every transaction to the borrowing smart contract, but for lending or depositing, they're just triggering with another event. Is that it, basically?
Well, I'm sure there's probably like an Aave V2 deposit table that you could like pull the same data with. It's just that like I found other people were using this, so I just used it. Because like this, I think is literally, this table is literally like the borrow smart contract. We could probably find it. I don't know where they would show the smart contract itself, but I think this is literally like when you borrow from Aave, like it uses this smart contract directly. Whereas this one is just like a reserve data one. But I imagine that there is a like a specific deposit smart contract that you could grab the same data from. But that might be the reason why they're different. But yeah, you can see the average didn't, we're doing it by block, so it doesn't change anything. So the issue that I was running into is you can see that this is 472,000 rows. And this is 106,000 rows. And I was basically trying to figure out like why that is. And what I noticed briefly is that for this, you can see, you know, USDT, USDC, DAI, actually I wonder where the, and then WETH or WETH, whatever you want to call it, there as well. And then with this one, like it seems like these are happening, like the deposit APY is changing, I guess, more frequently maybe. And it seems to like not be by block, which is weird because like we're pulling the EVT block time as time, which I imagine the EVT block time was only the exact time when a block was executed, but I actually might be wrong about that definition because, for example, you can see that a block time was 1711 today. And on here, well, we should go further back actually. So 1527, that's one block time. And on here, we have 1527, but then we've got like 1529, 1529, 1530, 1530, 1534, which is weird because we don't see that same, like essentially the timestamps are different, which I was confused about. So I don't know if like something's getting duplicated or what, but I think I'm pulling it for the same assets as well. Yeah. So I think it might be like an issue with this table. That's like why we're pulling this much data, but that's kind of where I stopped because I didn't know what the problem was.
Is a single block like the shortest time frame that we can like realistically collect?
That's what I thought. Well, I don't think there's any, I thought that there was no point in doing anything less because things wouldn't change until another block is mined because the batch of transactions that would change the data wouldn't happen until the next block is mined.
I mean, when you fetch a specific block, then is that data just a single row, or is it like an object that might contain other rows with like the time like 2 minutes later, as you showed there?
Yes, yeah, I'm not sure. Like, I don't really understand what's happening here. Like, I thought that the EVT block time would just be literally the time in which that block was mined. But maybe this is just like the Ethereum blockchain's like time zone, basically. It's just weird that the deposit, yeah, it's just weird that like there's so many entries in this database. Is what I'm confused about, because like all we're pulling is like the symbol, the liquidity rate, the block time, the block number. Actually, I guess the key thing here would be if we pull the block number, then we can see.
Yeah, but like,
Sorry,
if you're doing by block, it couldn't happen that, for example, in one block you had borrowed transactions, but you didn't have deposit transactions. Then you would, like, for extent, just have different timestamps for the both series. Unless you're looking like at literally every block of the blockchain, I think it is hard to get the same timestamps for both series.
Yeah, that's true. But I think the way that I'm like querying this is, I think the way that I'm querying this is like basically just checking at every block number. And that's it. Like we're not like, it's a simple query. It's not saying like anytime that there's a change, then like show the data, you know?
So is it like, I'm not really familiar with SQL, but is it like a for loop that you get like a list of block numbers and you just do a for loop on them? And for each block number, you get that specific time step.
Yeah, I think.
Okay.
At least that's what I thought.
So couldn't
yeah,
it be that all the data are like separate blocks, but the data that's sparser means that there just wasn't the change in that time, like that there wasn't any new information to write into the block?
Yeah, it's possible.
I mean, I don't know how often blocks get written, like whether it's possible
Every
for
13, about every 13 seconds on average, like on Ethereum.
Oh, so this is still way less than.
Yeah, I mean, well, this one is about 12 seconds. This one's 10 seconds, 4 seconds. The time can vary, but well, actually, that's wrong because we're. Yeah.
It is weird though, because I think you would expect sort of a pattern for the symbols, you know?
Yeah, I just don't know if I fully understand the query.
Just is Dune Analytics querying the blockchain directly, or okay?
So it's querying an archive node. At least I think. It probably says in their docs how they do it, or they keep it secret. But so if you index an archive node on a blockchain, then you're basically able to look back in the entire history of all of the blocks in that blockchain and grab any transaction that you want. So it costs usually, like if you wanted to do it yourself, you'd have to have like a lot of hardware to run that node. Or there's services like QuickNote, or you could use like, I guess, you could use like Google Cloud or AWS or whatever to rent a server to run that node. And then it basically gives you direct access to the Ethereum blockchain, like all of the data on it. And what Dune has done is they've mapped, they've done something where you're able to decode a smart contract into like SQL tables so that you can then query that blockchain data with SQL as if it was a relational database. So they basically, like, I assume they run like an archive node, and then they have something that allows you to, for decoded smart contracts that have been decoded into this relational database, they allow people to just query it as if it was a relational database. So like that's their main thing is, I mean, obviously like the whole UI and like the user-friendly nature of it, I guess, but is that they've built, basically turn the Ethereum blockchain into a relational database by decoding smart contracts into like tables that we're familiar with. And then the graph is similar, but they do it with GraphQL instead of SQL.
Yeah.
But you can't get such detailed data from the graph.
It depends on if you create the own subgraphs yourself, yeah. But it basically depends on the availability of the subgraphs that are available. So like how the graph works, actually I have it open right here, is actually I might have a better way to show this. Yeah, okay. So one sec. So here we have, for example, a subgraph that someone created, like so someone developed the subgraph where essentially, so it's very similar to Dune. So in this case on Dune, like for compound V2, if we wanted to look at, if we wanted to look at compound contracts, I don't know what it's called, but essentially someone would have had to decode the compound V2 smart contracts into, basically submit them to Dune, and then Dune would basically decode those into like a relational database, so into tables, like columns and rows, where each function or each smart contract is a table, and then all of the events in that smart contract are essentially the rows of that table. So something similar happens on the graph, but instead someone has to build a subgraph. Instead of decoding it into like a relational database, the smart contract is decoded into like GraphQL. And so someone actually has to develop a subgraph, and then and basically developing that subgraph is creating a mapping of like GraphQL to the smart contracts. And so in that sense, they're quite similar. And once someone has created a subgraph, then you're able, if it's on the hosted service, which almost everything is, you're able to just grab like the query URL, like the API endpoints, and query it however you want. So like in this situation, like we use like a free, GraphQL, something that can essentially query these GraphQL endpoints for like just some free service I found. And so in this case, we're using like the exact one I showed you, this compound V2 subgraph. And you're able to see like all of the data that they have mapped. And so in this case, like if we want all of this data, like the cash, borrow rates, collateral factor, exchange rates, etc., we're able to see that for different markets. So for example, this is, let's get a good one. So yeah, this is for USDC. You're able to see like the borrow index, the borrow rate, the cash, the collateral factor, aka like the liquidation, LTV, loan to value ratio, exchange rate, all these different things. The only difference is that it doesn't come out in nice rows and tables. It comes out in, I guess this is like JSON. I don't know exactly. GraphQL, I guess, but yeah, so in that sense, they're quite similar. They just do things a little differently.
Yeah. The problem with the graph for getting historical data, this one, is that, like Jakob was saying, if on SQL you would have to sort of make a for loop. In the graph, you actually have to make a for loop for each block of the blockchain and make a request for each block. So that could take quite some time. And comparing to Dune, you can just make the query and download it as a CSV. So it's much faster, but you can't really use on an API request. So you got pros and cons to both of them.
Yeah, and I use the graph because like for what I'm doing with my own project, like it's just all we need is real-time data, really. So, but yeah, for historical data, like, so for example, you can just do something like this and you basically get like all the data in real time for all these markets. Like what is a borrow rate right now based off when I just called that. So for like real-time purposes, it's great, but for historical data, as Yago was saying, it's kind of a pain to use. But anyway, that's kind of a background, I guess, on Dune and in the graph. But yeah, this is the problem I just need to think more about like why this is happening. So we don't have to dig into it now, but just wanted to give you some context.
I was thinking in terms of the model that maybe like if GraphQL is better for real-time data, then like I'm thinking once the model is trained and we want to predict real-time, then I guess then is when we might want to use GraphQL to get real-time data to like retrain the model again with the updated data set. But one thing that I'm not sure about is how much like how much data is actually relevant for predicting, say, I don't know, a week later. Like if we have a data set as we do now, like every half an hour versus a data set like every hour, will the prediction for 1 week in a 1 week later for two models trained on these two data sets be that much different? Because I guess the most recent data points have the biggest value. So if we have sparse data, sparse like historical data, but more dense newer data,
Yeah.
I'm not sure whether that is reasonable, but
Yeah, no, it is a reasonable analysis. I think a week is a big challenge. I'm hoping we can get there, but if you think about like as block numbers, like that's a lot of steps into the future you're gonna predict in. So that's super tough.
Yeah. I mean, I think logically, like it would be more helpful to maybe have it by block, but then you might be in a situation where you're kind of like overfitting.
Yeah.
You know, so I'm not actually sure what would be the best way to do it.
I think on the notebook, Archie was able to accurately predict 1.5 hour into the future. Is that a right, Jacob? So that would be 3 steps into the future with half an hour.
Mhm.
So yeah, it's still a slow start.
And this was the data that we needed, right? That we wanted to do by block instead of daily, right? The compound data.
Yeah, exactly.
Yeah, so I'm pretty sure all we have to do is this. I might be wrong. Oh, and take out the average, I guess. Division by 0 somewhere. Also, the errors that you get on Dune are annoying because like it doesn't specify where the issue is. But I imagine this is probably it. I don't know where the division by 0 is. Oh, it could be that. Anyway, probably won't get too much further on this right now, but I wanted to show you guys like the, I guess how it works on Dune. Now I got to figure out how to get back to Zoom because I closed it. How do I? Because I closed all the things. Where's it at? Can you see the Zoom on my screen? Can you see the Zoom stuff on my screen?
I actually cannot.
Oh, so it just looks like I'm clicking randomly. Yeah, I'm trying to find. Like I straight up can't find the.
I think you went to a different desktop.
Oh yeah. I only have one desktop open though.
Oh.
Now it says like this is weird. Oh, maybe I did go to a different desktop. No, I didn't. I just have the one desktop.
I think you can just take it back. You can take the screen back.
Yeah, so you can do that. Because I closed the controls and now I can't open them.
Yeah, they still haven't figured out this. This has been happening forever. It's always such a weird.
I'm more of a a Google Meets guy, so yeah, you can take the screen back whenever.
Okay.
Unless there's more you guys wanted to look at, but that's pretty much it.
I think that's great already. To your question, Jakob, like on whether when the model is ready, whether we would use the graph for Dune. I think the graph is great if you are collecting that data every block and then storing on an external database. And I think that would be like the ideal way of working through this. Maybe like you set up an initial like data set with Dune, and then you create a routine using the graph to externally store that data.
Yeah, I guess this is something probably for the storage pod as well. Like if we could like set up an IPFS node for storing this data to the graph, and then have like you can something like, I think it's called Streamer, the blockchain that deals with like continuous streaming data. So yeah, I guess when it comes to actually deploying the model and like updating it with new data, there's so much more work to be done than just like playing around with a model in the notebook.
Yeah. Do you think it would be cool to go over the notebook, Jakob? I think it would. I think that would be nice.
Yeah, sure. I should have it open. Oh yeah. Okay. Okay, can you see this?
Yes.
Cool. So yeah, this is Arshi's notebook. Yeah, this is where, so Arshi got the yeah, this is the with the Tabula model for the target window being 3 time steps into the future. Oh yeah. Yeah, so for 3 time steps it's 85%. And then it gets worse over time. I mean, I guess this probably means that data shouldn't be leaking from anywhere, as we talked about that last time. We can maybe take a look at the PyTorch forecasting, which Arshi also got working. Yeah, so basically, I think PyTorch forecasting, they do have documentation, but I think they're rather new. So, which is why it's a bit confusing at times. And I don't think they have any tutorials on like specifically financial data. They have time series data, but it's a bit different. So they have like this time series data set, which I think somehow derives from PyTorch Lightning as well. I think they said they want to be like the fast AI, but for forecasting. So this group IDs should be probably the columns we would use for like the other time series. So if we want to predict both the DAI borrow rate and the USDT borrow rate at the same time, although not entirely sure. Yeah, and I think she even got it training.
Yeah, but I think you didn't show the results. That would be cool to see.
Yeah, I think so. Yeah, no, it didn't show the results. Although I thought I've seen them somewhere. I don't think we'll be able to get it run right now because I don't have a GPU. Maybe if I can try opening this in a Google Colab. Maybe.
Yeah, but like I had some stuff that I think it's good to talk
Yeah.
about. Some questions that I had. Like the first one was like you were using the temporal fusion transformer for this, I just wanted to know like why was it because it just seems as good as any other, or did you have any specific motive for this?
I think it's the only one they have. Like it's the base model that PyTorch forecasting implements. Let me see if I can find. Oh no, this isn't what I wanted to do.
So it's pretty much their quick start model for you to start
Yeah.
forecasting time series.
Yeah. So yeah, I think I don't know which other models they have. Yeah, basically. Yeah, I think the temporal fusion transformer is the main one they have, and yeah, they don't have that many. But yeah, I mean we can try these other ones. I'm not sure what deep AR is. Yeah.
I think it's nice that it's nice for using the fusion transformer. I think it's pretty much focused on forecasting time series. Just wanted to know like if you had any particular reason for that. Another question that I had was like when you there's this when you call the method for training the data, you have to pass a lot of parameters for the training, such as the encoder length and also the, I mean, I feel sure it will be better.
Yeah. This one you mean?
Yeah, exactly. And then, yeah, just a lot of parameters. And I just want to know, like, if you chose them randomly or?
Yeah, I think I actually had the exact same question to Archie because I had no idea how to choose the encoder length. I think it's more or less random. Yeah, I don't think I think that's like something we can experiment with.
Yeah, I think a good practice would be just running with the results for different parameters and then comparing them. But yeah. And also one thing that I want to talk about is, especially on these parameters, you have these two like specific ones which are the time varying known reals and the unknown reals. So like from what I read the documentation, the known reals was the ones you would know in the future, and the unknown the ones you wouldn't know in the future. And I just didn't understand why all of those columns are in the known one, because to me it seems like we wouldn't know them in the future. Pretty much all of those feature columns. So I'm not sure if that's a question to it.
Not sure. I think. Yeah, no idea.
Yeah. It's a little bit confusing to get a model like that and then just trying to.
Yeah, I was. So that's one thing that I was thinking of as well. Like, if I feel like I don't think it doesn't make much sense to me for us to predict like one column when we know the other columns in the future, because like in reality we don't know the columns in the future. So it's like what would make more sense to me is basically predicting like the entire rows.
Yeah.
Although, yeah, I'm not sure if there's the data visible anywhere. Yeah, so probably like both the deposit rate and borrow rate will be different. And are any like none of these seem to be deterministic, right?
Yeah.
Like not even the supply volume.
Yeah, I think the best practice would be separating the time series for tokens, like using the group ID parameter, like just use the token symbol as the group ID section, and then put every variable as unknown. I think that's what makes sense for me, and then see what the model will pop up. That's something I can do asynchronously. But yeah, I was.
When you say unknown, do you mean Just like there's no label on the column, or
Like I was a little bit unsure, but like what the documentation said, example they had is like a known parameter in the future is, for example, you're selling a product and you know how much the price will be in 3 months, but you don't know how much the demand will be. So it would be some time varying variable, but that you do know the value in the future. And I think that's not the case for any of the variables we have in here.
Yeah, I think in terms of training, it might be good to just like if we're predicting just say the DAI borrowing rate, then I think it like the transformer is a large enough model that we might as well just pass the other tokens to it as well, because they might influence each other. I don't remember if the correlations notebook also had correlations between tokens, but I think it did.
I don't remember actually.
I can take a look.
Also, when does this, I forget when this data was pulled.
I think it does it just between ETH and the.
Oh yeah.
Because the last week, like the market crashed. So it'd be interesting to see like
Yeah,
that data in here as well.
but it's still that initial compound data set, so probably like already a month ago old.
Well, it would be good to see whether we can predict the crash from the
Yeah,
data we don't have.
True.
I feel like also one thing, I'm not sure how feasible that is, but even if we can't predict the crash itself, we could sort of like pass it as a parameter, like saying it's going to crash, and then like see how the borrowing market would react to that. Okay, so this is the correlation one.
Yeah. So.
Yeah,
Oh,
it has higher correlation with other stablecoins, which is kind of expected. It has a low correlation with ETH.
seems like the stable coins have overall low correlation with.
Each other. Yeah. They're very low correlated with ETH though. So
I guess is ETH taken as collateral for borrowing stablecoins?
yeah,
Like what, is that like most common that you deposit ETH and borrow DAI?
Yeah.
Okay.
like if people are bullish on ETH, they think it's going up, then they're gonna deposit ETH and then borrow stable coins to buy more ETH, basically.
In that case, I guess it makes sense that they wouldn't be correlated, because if ETH is used as collateral, then the borrow rate for DAI means that there's going to be, the higher the borrow rate for DAI means less borrow rate for ETH.
Yeah, but like the ETH supply volume should be correlated with the borrow volume for the stable coins. Can you check if that's the case?
Yeah.
Like for the borrow volume from ETH and then the. Actually, the deposited volume for ETH, so the supply volume. Yeah, it's kind of correlated. It's a 0.58. It's not that big. 0.667 with USDC. So yeah, this is why I think using the time series separated by for each token, it's helpful, because I think there's a lot of stories in there.
Yeah.
Because like if in one block you can see a lot of deposits in the ETH pool, and then you could predict a higher borrowing volume on some stable coins. That's still a very small time step into the future to predict, but I assume that should have some good results.
Yeah, I plan to look more. I need to understand the PyTorch forecasting a bit more, like read more of the documentation, because there's some of the parameters are still kind of weird.
Yeah, agree. I read a lot of the documentation. I'm still a little bit fuzzy about how it works. We could host maybe a separate hacking session just for that, or even
Yeah,
on this one. But I think a separate one would be nice.
yeah, I guess we can also try to like just train it on like Google Colab with a GPU and test it for like, say, different prediction and encoder lengths, just so I wonder if there's something like an encoder length finder, like there's the learning rate finder. Bust it out.
Do you think that there's a chance we could have better results by inputting less variables? It could reduce overfitting, maybe? I think that's really what we got to do now. I think we just got to try a lot of different approaches to this and then compare them. And it would be good to do this on a separate hacking session. I think I'm gonna bring it up to Richard if.
Yeah, it sounds good. Yeah, and in terms of, so what are you thinking in terms of the data? Do you all think that it's best for us to have just block by block?
I think so.
Yeah. Sorry, I'll definitely have that. Like my time's a little bit more freed up now because we are closing our seed round, so it's just been a bunch of legal shit. So that's almost pretty much done now, which is great. So
Congrats.
Thank you. Yeah, it's just getting signatures now, which might be more annoying, but everyone's committed, so shouldn't be a problem. But I'll have more time to like mess around with the data and whatnot. I just uploaded the just a more recent data set for Aave v2 of the borrowing rates in the Discord, and then I added a few variables, but otherwise I'll try and do the same thing, because what we're missing is block by block data on compounds and then block by block data on maker. But like I said, I should have more time. So by next meeting, it's won't be a problem to have all that data. So apologies for not having it for today.
Oh, no problem. And yeah, I think we just take the updated data sets and then just repeat this analytics, hopefully with more understanding of how PyTorch forecasting works. And maybe we can get a good result already. Let's see.
Yeah, we should definitely I mean, maybe this is overcomplicating it, but also adding in like liquidation events as well could be pretty interesting. Although I think like if we just have the data on the borrow rates and things like that, and we're trying to predict borrow rates, I'm not sure how much liquidations will affect that, because I think it'll automatically be reflected in the rates. But it's also a really small data set I could share as well.
Yeah, but that's interesting actually.
Yeah, I think I'll upload it.
Yeah.
So it would just be like a 0, 1 type of column, like this time step was liquidated, not. Yeah.
Yeah. Okay. Nice. I think that's enough for today, right? You got anything else to add?
Yeah,
Okay.
sounds good.
So thank you very much. See you next week. Bye, guys.
Thanks, guys.
Bye,
See ya.
everyone.